Hey guys, welcome back to Helper Function. In this video, we will discuss a very popular interview question, single number. So the problem statement says that given a non-empty array of integers, every element appears twice except for the one. And we need to find that single one. So the problem itself guarantees that there is only one element that is unique, otherwise every element has appeared twice. As for this example, we can see that 1 and 2 have appeared twice while 4 is unique. So we will return 4 as our answer. Now let's see how to solve this. Now the brute force approach would be to go through every element and check whether it is present one more time or not. But this approach will require two for loops, one for the current element and another for going through all the elements. This will make its time complexity order of n square and it will not work in an interview. Another approach would be we take a map and store the frequency of every element in one go. And now we again go through all the elements and one of them will definitely have frequency 1. And thus we will return that element. Let's say for this example, I have stored the frequency of every element in my map. And now when I go through these elements one more time, when I am at 4, I will see that map of 4 is 1, which means that 4 is unique in this array, and we will return 4. Now to code this is pretty simple. We take an unordered map which will give our result in order of 1. Now in the first for loop, we are incrementing the frequency of each element we come across, and thus at the end of this loop, we will have the frequency of all the elements stored in our map. Now in the second for loop, we go through these elements one more time, and whenever we get an element with frequency 1, this means that this element is unique and we will return this element as our answer. And because the answer always exists, we will never reach to line number 14. Thus return 0 does not play any role in this code. So now our time complexity is reduced to order of n, but the space complexity here is also order of n, because we are storing the elements and its frequency in a map. And because this problem is very popular, in an interview you will be definitely asked to solve this problem without using extra space. So let's see how to do that. Now there is an observation that we can draw using bitwise XOR operation. Now if you don't know what a XOR operation is, bitwise XOR gives 0 for similar bits and gives 1 for different bits. Thus 0 0 and 1 1 will give 0, while 0 1 and 1 0 will give 1. Now the point what I want to make here is that bitwise XOR of similar elements will give 0. Let's say for number 11, if I do bitwise XOR between them, I will get 0 because they are having similar bits at every position. Thus doing XOR operation for every two similar elements will result in 0. Now looking into the broader picture, as we have been given that every element appears twice in the array except for the one, all these similar elements will cancel out each other when performed a XOR operation, as these two ones will become 0 and these two ones also. Thus we can XOR all the bits and all the similar elements will cancel out each other, and what will remain is the unique number that is our answer. So we will be performing this operation. We take an integer k and initialize it to 0. Now for every element in the array, we will perform its XOR operation with k, and finally we will return k as our answer. So let's look at this example. Currently my k is 0. When I will XOR it with 4, it will become 4. Now when I XOR 4 with 1, it will become 5. Now XORing 5 with 2 will result in 7. And now if I XOR 7 with 1, it will become 6. Thus the contribution of 1 gets removed. Again if I XOR 6 with 2, it will become 4. Thus contribution of 2 also gets removed. Thus at the end, my k will represent the unique element present in the array. Now to code this is much more simpler. We declare an integer k initialized to 0, and now in the for loop, every time we will perform the XOR operation between k and the array element. And finally we will return k as our answer. Now the time complexity for this problem remains order of n, but the space complexity here is reduced to order of 1. That is, we are not using any extra space. So this was all about the problem. I've put the problem link in the description so you can go and solve it. Do like, share and subscribe to the channel for more such videos. Thank you for watching.